And welcome to this online revision session for AQA N2, in which we will be considering the January 2010 question 3 on moments of parallel forces. So in this question, it's the typical question that you'll be hopefully familiar with, of a plank, and it's being supported at A and at B. And there is also a mass of 20 kilograms which is placed on the plank at point A. First part of the question asks you to draw a force diagram to show the forces acting on the plank. So the key things we need to draw in on our diagram, which you may well have to draw separately, but I'm going to draw it on this diagram to show the forces. We will have a reaction at A, where the plank is supported. We have a weight of the mass acting down in this direction, so that's a 20g force. Remember, it's the mass times gravitational acceleration to get the weight. Similarly, there is a reaction at B, and then finally we need to show the weight of the plank itself, and so the weight of the plank will be acting through the centre of the plank, and so that force will be 30g. So altogether we should be showing 4 forces acting on the plank. 2 marks for that. If you're showing all 4 forces and clearly showing them labelled as well, that will give you the 2 marks. If you've only got the forces and they're not clearly labelled, then you will only get 1 mark rather than 2. Okay. Part B then says, show that the magnitude of the force exerted on the plank by the support at B is 19.2g. Okay, now we need to consider then how we would do this. There are 2 forces that we don't know, RA and RB. Key thing here then is to use moments, because if we choose an appropriate point about which to take moments, then the fact that we do not know RA will not matter if we choose A as the point about which to take moments. So in other words, to do part B, we will take moments about A and take anti-clockwise as being positive. So the moment of RA, because it's through A, is 0. The moment of the 20g is through A, so that is 0. So the moment we are interested in would then be the 30g, and we need to work out the distance that 30g, that's the centre of mass of the plank, is from A. Now if you remember, the plank had a length of 8 metres, so the centre of mass is in the middle, so that makes it 4 metres from the end, but we're 0.8 in from the end at A, so that means the distance of the centre of mass from A will be 3.2. And that motion around A is negative. Okay, then the only other force we have to consider is RB, which is the one that we're interested in, and its distance from A is 5 metres, so we have to multiply RB by 5. And since we're in equilibrium, that turning effect, total moments about A, must equal 0. So now if we rearrange this, we know that RB must be equal to 30G multiplied by 3.2 and divided by 5. Now our answer is in terms of G, so we can divide 30 by 5, which is 6, and then do 6 times 3.2, which gives us 19.2 newtons, which checks out with the answer that we are given. 3 marks for this. For taking moments about at an appropriate point would give you 1 mark. For the having 3.2 as that distance of the centre of mass away from A will give us a mark, and then rearranging and obtaining the correct result will give us our 3rd mark. Okay, moving on then to part C. Says find the magnitude of the force exerted on the plank at the support A. Well, to do part C, we know that the sum of the forces must equal 0 for equilibrium. Total sum of all the forces must equal 0. Okay, so we know then that RA plus RB minus 20G minus 50G, all those forces must add up to 0. And so RA must be equal to the 50G, that's the 20 and the 30, taken over to the other side, and then we got the RB's 19.2, so we need to take away 19.2. My apologies, I missed out the G when I wrote that answer down there. Said one thing, wrote another. And so this is 50G minus 19.2G, which will give you 30.8 G newtons as our answer. 2 marks for that. 1 for recognising that you needed to resolve the forces vertically, and then for obtaining the correct answer gives you the 2nd mark. Finally, in part D, to get your 1 mark, explain how you use the fact that the plank is uniform in your solution. Well, we needed to identify where to put the centre of mass when we were doing part B to this question. Okay, and so we used the fact that it was a uniform plank to use the symmetry of the plank to put that the centre of mass was acting through the midpoint of the plank. Okay, and that's what you need to write down in order to obtain your 1 mark in part D. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.